So sometimes we have a couple terms in the bottom. So we're going to need to rationalize these with our conjugates. So let's remind ourselves about radical conjugates. Remember, if we have the square root of a times plus the square root of b, the conjugate of that is the square root of a minus the square root of b. And if we multiply those, we found out that we get a minus b. Okay, and you can multiply that out for yourself and simplify, and you'll end up with a minus b. Notice there's no radicals over here. Okay, well, that's going to be real useful. So here we have a fraction, and we don't want any radicals in the bottom. So we got to make the square root go away. Well, to do that, we're going to use its radical conjugate. So the key is to multiply the denominator by the radical conjugate. All right, so let's do that. So let's multiply the denominator by the square root of 5 minus x. And what you multiply the denominator by, you got to multiply the top by the square root of 5 minus x. Okay, the same thing. So let's see what we end up with. Now, let's use the rule a plus b times a minus b equals a squared minus b squared. Okay, let's use that. Okay, we've proven that. Hopefully you've seen that. You can distribute this out and you'll see why it's a squared minus b squared. So if we multiply conjugates, we get this. Okay, so if we're going to multiply these, what are we going to get? Well, we're going to get the first thing squared, the square root of 5 squared. What is the square root of 5 squared? Well, that's just 5, right? And then we're going to take this second term there and square it, x squared. Up top here, well, all we can really do is just distribute that 5 out. 5 times the square root of 5 minus x. And we're done. Our only goal is to rationalize the denominator. That's all we care about right now. Well, let me back up. Okay, and simplify. So here we can't really do any simplifying. Now be careful. You might think you want to divide those 5s, but you can't because these are now binomials. There's a 5 in the first term, but there's not a 5 in the second terms. So you can't factor that and divide. You're done. We're done with that problem. All right? So how about this one? Well, we want to rationalize the denominator. If there's not parentheses, you probably should put parentheses around that there and the top because we're going to be doing some multiplying. And we're going to multiply by the conjugate, the square root of 3 plus the square root of 2. Okay? All of this is going to get distributed. Now we have, again, our little rule here, a plus b times a minus b equals a squared minus b squared. Okay? So that's going to help us on the bottom. Just we can jump right to it. We're going to take the first thing squared. So if we have the square root of 3 squared is 3 minus the second thing squared. The square root of 2 squared is 2. Now the top we have to actually multiply out. So we're going to need 3 times the square root of 3. We got 3 times the square root of 2. We've got square root of 2 times the square root of 3. That's the square root of 6. And the square root of 2 times the square root of 2 there, that's going to be square root of 4. And that doesn't simplify to much. 3 square root of 3 plus 3 square root of 2 plus the square root of 6 plus 2. We can't do much with that. But what's the bottom? The bottom is just 1. So does the bottom really need to be there? Nah. We don't need the bottom there. Because when you divide by 1, it doesn't change anything. Let's try that again. Okay. That's the idea there. Okay. Hope that makes sense. So part of the reason why we do this is because we're going to run into situations like this where we need to combine these. And in order to combine these, we want to have a rational denominator. All right. So we're going to rationalize both of these by multiplying by the conjugate. The conjugate on this fraction is x plus the square root of 2. X minus the square root of 2, the conjugate is x plus the square root of 2. For this first fraction, which we're going to deal with separate, this is x minus the square root of 2. So we already have x plus in this one, so we need x minus. So let's clean up these fractions separate. And so on top here, we get, just distribute here, 3x plus 3 square root of 2. The bottom, we're going to get the first thing squared. That's x times x, that's x squared. The middle terms drop out, and we got the square root of 2 times the square root of 2, so it's minus the second thing squared, which is 2. Over here, we got the first thing squared, that's x squared. The middle terms will drop out. Square root of 2 times the square root of 2 is 2, and it's going to be a minus, because that's negative times a positive. And at the top, we'll just distribute that out. 2x minus 2 square root of 2. We got two fractions. Can we add those fractions? Sure, because they have a common denominator. Look at the denominator. X squared minus 2. X squared minus 2. The denominator is x squared minus 2. Now we have 2x plus 3x. That's 5x. Negative 2 square root of 2 plus 3 square root of 2. That's just a positive 1 square root of 2. And that's it. Can't go any further. All right? So, what if we have different indices? Last little situation here for us. All right? So, when we're working with radical terms of different indices, we want to write them with rational exponents and simplify. All right? So, let's write this with rational exponents. So, we have this x plus 5. Don't try to multiply this out, by the way. Do not distribute this forward. It does not, because this is a plus. You can't do that. If this was a multiplication, it'd be a different story. All right, but we can't do anything with that. So remember that this is we got x plus 5 to the 4th power, and this is 6th root, so we're going to have that as a fraction, 4 over 6. And now we have x plus 5 on the bottom. It's a square root. That's a 1/2 power. All right? Well, remember when we are dividing, now notice we have the same base, x plus 5 and x plus 5. When we're dividing, if we have the same base, we can just subtract the exponents. So this gives us x plus 5, and we have 4/6 minus 1/2. So all we got to do is remember how to subtract fractions. Remember how to do that? We need a common denominator, right? I think we can change the 1/2 into 6th, right? Multiply top and bottom by 3, and that's 3/6. So we'll multiply by times 3 times 3. And so this is x plus 5 to the 1/6. And then the directions here say write your answer in radical notation. So we want to write our final answer as a root. So this is the 6th root of x plus 5. Okay? That's the idea. So rational exponents come in real handy. Okay? So here we got some rational exponents. We got x to the 5/2. Remember, the index is 2 there. So we got 5/2 times x to the 2/3. Well, we're multiplying, so we're going to add those exponents. So all we got to do is add the fractions, but we need a common denominator. Common denominator for 2 and 3 is 6. So I want to change these into 6. If we multiply top and bottom by 3 there, we're going to get 15/6. Multiply top and bottom here by 2. And that's going to give us 4/6. And so that's 15 plus 4 is 19 6th. Okay. Now, we're going to go to radical notation here. And so there's going to be some simplifying. So we can just write it as x to the 19th, the 6th root of x to the 19th. We need to simplify that a little bit. Can 19 be divided by 6? No, it can't. But 18 can. So we're going to use the radical product rule to break this into x to the 18th. Okay, that could be divided. And that is 18 divided by 6 is 3. And one of those x's is going to have to stay underneath. Okay? That's it. Now, by the way, a little side note. Let me show you something kind of interesting. What if we wrote this as a mixed number? Remember how to do that? What's 19 divided by 6? Well, 6 goes into there 3 times with 1/6 left over. 19/6 is the same as 3 and 1/6. Okay? Look at that. 3, and there's a 1/6 power. So there's kind of a slick way. I'll leave it at that and let you kind of think about that. But there's kind of a slick way, if you think of that as a mixed number, to jump right down to the simplified version there. Okay? All right. One last one. If you want, you might pause this and try it for a good practice. Again, notice that we have different indices. So we got to write this as with fractional exponents. We've got all of that to the 1/3 power. We have AB cubed to the 1/2 power. Now, this is all multiplied. Notice, there's no addition. All multiplying and division. So since it's multiplying, we can apply that. We have power to a power, so 2 times 1/3 is 2/3. 5 times 1/3 is 5/3. On the bottom, we have 8 to the 1st times 1/2, so that's 1 times 1/2 is 1/2. And then we have 3 times 1/2, and that's 3/2. Well, we have A's and B's we need to simplify. So we're dividing this divided by this. So we need to subtract exponents. 2/3 minus 1/2. And then B is 5/3 minus 3/2. Because we're dividing B to the 5/3 divided by this. And so we're going to subtract the exponents. Okay. Well, we need common denominators. 6 is our common denominator. Multiply top and bottom by 2 here, and you get 4/6. Multiply top and bottom by 3 here, and you get 3/6. Clean that up in just a second. 6 is our common denominator. Multiply each top and bottom by 2 here. Multiply top and bottom by 3 here. So 9. And that leaves us with A to the 1/6 times B. 10/6 minus 9/6 is 1/6 also. So this is really AB to the 1/6, which just turns out to be the 6th root of AB. That's it. Simplifies pretty nicely. All right, hope that helps. Hope that makes sense. Thanks for watching this, and keep at it there, one step at a time, and you'll get there.